Hello students, welcome back. Myself Srimati Ranjana Bhandare, Assistant Professor, Department of Mathematics, Government First Aid College, Hulkoti. In this video, we are going to discuss BSc 5th Sem Paper 2 Numerical Methods, the third unit, Finite Difference. This is the third session in the finite difference unit. So in the last session, we have learnt about forward and backward differences, and here we are going to study construction of forward and backward difference tables. So first we shall define forward difference table. A tabular arrangement of first, second, third and other forward differences is called a forward difference table. Forward difference table can be drawn in like this. That is, in the first column we are going to write the x values, and in the second column we are going to write the y values corresponding to the x values. And then we are going to write the first, second, third and other forward differences. The first forward difference, this forward difference of y naught is nothing but the difference of y1 and y naught. And the first forward difference of y1 is nothing but the difference of y2 and y1. And the first forward difference of y2 is nothing but the difference of y3 and y2. And similarly, the other differences are calculated, and nth forward difference of yn minus 1 is equal to yn minus 1. And the second forward difference is the second forward difference of y naught is equal to first forward difference of y1 minus first forward difference of y naught. And the second forward difference of y2 can be calculated by using the difference between first forward difference of y2 and first forward difference of y1. Similarly, the other forward differences are calculated, and then similarly the third forward difference and other forward differences are calculated. And here the first entries in the tables, namely first forward difference of y naught, second forward difference of y naught, third forward difference of y naught, and then so on, nth forward difference of y naught are called leading forward differences. So here we shall have one example for the construction of forward difference table. So construct the forward difference table for the function y is equal to x square plus 2x plus 3, where x is equal to 1, 2, 3, 4, 5 and 6. So here in the first column we are going to write the x values, and in the second column we are going to write the y values corresponding to the x values. So that is, in the equation y is equal to x squared plus 2x plus 3, substitute x is equal to 1, 2, 3, 4 and 5 and 6. So we get the corresponding y values. And then the first forward difference is calculated. So that is the difference between 11 and 6 is 5, and the difference between 18 and 11 is 7. The difference between 27 and 18 is 9. The difference between 38 and 27 is 11. The difference between 58 and 38 is 13. And to calculate the second forward difference, that is the differences of the first forward difference. So here 7 minus 5 will be 2, 9 minus 7 will be 2, and 11 minus 9 will be 2, and 13 minus 11 will be 2. So similarly, we can calculate the third, fourth and fifth forward differences. So as here in the second forward difference table, we have got all the elements, all the numbers are equal, so that the third, fourth and fifth forward difference elements becomes zeros. And here the first entries, that is 5, 2 and 0, are called leading forward differences. So now backward difference table. A tabular arrangement of first, second, third and other backward differences is called backward difference table. So the table as follows. In the first column we are going to write the x values, and in the second column we are going to write the y values corresponding to the x values. And here we are going to calculate in the reverse order. That means we are going from below to up. That is yn minus 1 is nothing but the first backward difference of yn. And then similarly by going in the reverse order, so here we get the difference of y3 and y2 is nothing but the first backward difference of y2, and the difference of y2 and y1 is nothing but the first backward difference of y1, and the difference of y1 and y0 is nothing but the first backward difference of y0. And similarly the second backward differences, the difference of this first forward difference of yn and first forward difference of yn minus 1 gives the second backward difference of yn. And then similarly here the difference of first backward difference of y2 and first backward difference of y1 gives the second backward difference of y1, and the difference of first backward difference of y1 and first backward difference of y0 gives the second backward difference of y0. And similarly we can calculate third, fourth and other backward differences. And here the last entries, first backward difference of yn, second backward difference of yn, third backward difference of yn, and then so on, are called leading backward entries. So now we shall have an example for the construction of backward difference table. Construct a backward difference table for the function y is equal to log x, given that so x is equal to 10, 20, 30, 40 and 50, and corresponding to the x values we have the corresponding y values. So first write the backward difference table. So in the first column we are going to write the x values, and in the second column y values corresponding to the x. So first backward difference of y is nothing but the difference between these two, that is 1.6990 minus 1.6021, and the difference between these two will be the 0.1250, and the difference between these two entries is 0.1761, and the difference between these two entries will be it is 0.3010. And similarly the second backward difference is the difference between these two entries is this one, minus 0.0281, and then the difference between these two entries is 0. Minus 0.0511, and then the difference between these two entries is minus 0.1249, and then similarly the difference between these two gives the third backward differences, and the difference between these two will give this one, and again the difference between these two gives the fourth backward difference. And here these last entries are called leading backward entries. So similarly we can construct the forward and backward difference tables for the following examples, and these are the references which we have used. Thank you for watching the video. Have a good day.